All right, up next we have Hunter Hermes and Brendan Kwick from physics, and they will be presenting on research and development of a polycarbonate solar water heater.
Good afternoon, my name is Hunter Hermes, a senior applied physics major.
I'm Brendan, a junior physics and engineering major.
We did our research through the physics and astronomy department, and our mentor was Dr. Pierson. So we focused on building a solar powered water heater that's used with a different material than what's currently being used today. And just breaking down a solar powered water heater for those of you who aren't familiar with one, it's typically a large panel where water is flowing through it. Sunlight hits this panel, heat energy is transferred from the sunlight into the water. The water then warms up and then is pumped through, where it's used in different variations such as just like hot water, heating homes, etc.
This isn't uncommon. This is obtained in a few different ways, but there are a lot of different problems with this. Current model is geothermal, where water is put down into the earth where it's heated by the earth's warmth and then brought back up and then used to be heating homes and domestic hot water. There are other solar panels in use now where they have a flat copper fin that collects heat and then transfers it to a copper pipe where water is pushed through. This also raises a problem because they're much more expensive and a lot more labor has to go into installing them for that, as well as geothermal, where it's very specific to where they can be used. In pre-constructed homes, it is very difficult to put those in due to the drilling that needs to occur, and for a lot of different loops, they need to be run horizontally, so it takes out a lot of trees and a lot of the different habitat around it.
So we used a polycarbonate material instead of the copper fin design, and while a polycarbonate material does not conduct heat nearly as well as a copper fin would, what it does do is it has a much shorter distance the heat has to transfer, making it theoretically 3 times more efficient. Because it's theoretically 3 times more efficient, we're going to increase the flow rate, and we're going to produce a large volume of warm water. Therefore, less heat is lost to the environment. After that, we're going to couple it with a heat pump. Now, what a heat pump is if you have like a window AC unit that cools your room in the summer. If you were to take that AC unit and flip it around, it would actually heat your room. Now, a heat pump's similar to that. So we're going to use this large volume of warm water. We're going to pump it through the solar water heater where it warms up and then into the heat pump. From the heat pump, it then condenses the large volume of warm water into hot water. This hot water then can be used for things like hot water or to heat houses, etc.
Yes, like we said before, this would be very helpful for being brought into a lot of domestic homes. Like we were saying, it is a lot less expensive than current models that are on the market, so it makes it a lot more available to the average consumer where they don't have to put up this large capital to pay for this. And going forward, we hope to look at creating it more manufacturable and having a case where it is less expensive to have it installed, where a lot of the price comes from now due to all the difficult plumbing needs and fastening issues. Right. Thank you.
Questions? Judges?
So what stage of development are you at now, and what would you anticipate the cost of the unit to be?
So we've built a prototype and we've done experiments on it. And we're just at the point where we want to make a theoretical model on the computer to determine which parts we need to focus on the most, where we lose the most energy. So going forward, we do the computer model and then we'd build a new prototype, which would be something potentially where we could manufacture it, where it'd be sold. As far as how much it would be, because it's theoretically 3 times more efficient, in theory we would need kind of like 3 times less the material, and we don't have an exact number for you today, but that's something we need to work on, and because it's confusing with manufacturing and everything else like that.